Hello students. Yesterday you were looking at this information and you were determining what the resultant vector, this vector right here, was from the two component vectors. Today what we'll do is we will look at determining what the component vectors are from that resultant vector. So in this paper right here, you need to have this one out. We have this red dashed line right here is going to be the resultant vector, and they tell us it is at 10, so we'll call this meters, and the angle for this is 28 degrees, and it's towards the south of west direction. All right, so from the resultant vector, now they're saying, hey, I want you to solve for what the component vector is that's needed to make up that particular resultant. So let's take a peek at what is needed to do this. We cannot use the Pythagorean theorem. The Pythagorean theorem requires us to have two sides of this right triangle, and I only have one side of it, and that's it. So the Pythagorean theorem is out the window. What we have to use is we have to use some trigonomic functions in order to determine what that component vector is. So let's do that. On your graphing calculator, one that's like this right here, one of the TI-83s, to make sure that you have your calculator in the right mode, you have to actually press the mode button right there. And you can see if I move the cursor down, if I move it down 3 spots, you're going to find a spot that is describing radians and degrees. I need to make sure that the degrees is the one that's bolded. If it's not bolded, what you have to do is you have to use the arrow keys right here in order to change it from radians over to degrees. Once it's on degrees, you hit enter and you're all good. You're in the right mode to do any of the calculations. If you have one of the Texas Instrument calculators that looks like this right here, what you'll notice is in the lower right corner of your screen, it's going to say either RAD or it might say GE or DEG. What we need to make sure is that it says DEG for degrees. To change this, you would press this button right here, and once you press that, that's going to change it to the different functions that your calculator can do calculations in. We have to make sure that this down here says DEG. To work out any of these types of problems, you need a mnemonic. A mnemonic is just a way for us to help remember what the different formulas related to trigonometry would be. So the easiest one that we can come up with, there's different ways that people say this. I like to use the mnemonic SOHCAHTOA, that you have the so part right here, you have the ka and toa. What these stand for would be the S here is the sine function. We have the C is the cosine function, and then the T stands for the tangent function. Now on your calculator, you're going to see each one of those trigonomic functions right here. So we have the sine button, we have the cosine button, and we have the tangent button. So we're going to use those. It's not that you have to memorize all of the different trigonomic ratios, because the calculator is going to do the work for you. That's the easy part. All right. So we have sine, and what we will do is we'll put a little theta in front of that. The O represents the opposite side, so we'll put opposite here, divided by, and then the H represents the hypotenuse. So if we have cosine theta, the A represents the adjacent side, the H represents the hypotenuse, and then for tangent theta, if we have the O, that's your opposite, over the A, that's the adjacent. So the most important part of this is to get the sides of your angles, your vector diagrams done correctly. So we've already practiced this. We had a little video over it. We had a little quiz over it. So now we're going to have to actually apply this. If the 28 degrees is me standing here and I'm looking out of that corner, what's the side that is opposite to it? This is the side that's opposite to it. Which one is the hypotenuse? Well, the hypotenuse is always the longest side, or it's always across from that 90 degree. So in this particular problem, we have the opposite side and we have the hypotenuse. We need to find the trigonomic function that has opposite and hypotenuse. Why those two? Because that's what's given to me here and here. Tangent does not have it. Tangent has opposite and adjacent. That's not going to help us out. Cosine has adjacent and hypotenuse. That's not going to help us. But sine, however, does have opposite and hypotenuse. So that's the one that we're going to use. When we plug this in, you're going to have sine 28, that's your angle, equals the opposite side. You don't know what that is. All right, and I'm going to put in, you could leave it as x, or you could put in the word OP, or the abbreviation OPP. It doesn't really matter. And then we have 10 down here. Now, we want the x by itself, so you'd have to multiply both sides by 10, correct? So we're going to write this out. I'm going to put sine 28, and I'm purposefully doing this. I know that you could just put that into the calculator, but there is a very common issue that pops up. So let me show you what that is. See, if we, I didn't mean to have everything go away. If we have the calculator and we type it in just like this, all right, where we type in the sine 28, if I go sine 28, first off, what is that value? What's that trigonomic ratio? What is that? That's going to be a value of 0.4695. All right, now if we multiply that by 10, your value, that the length of that side, is going to be 4.6, let's just say 4.7, we'll round it off. We'll say 4.7 meters. And if you're looking at the diagram, that kind of looks like it would be right. 4.7, that looks about right. But how about your calculator? If you just put that in and you go sine 28 times 10, if you do that, ooh, we come out with a negative number. Can you have a negative distance when it's like that? No, you can't. See, when you put it into the calculator like this, it's not getting the trigonomic ratio of 28. It's getting the trigonomic ratio of 280. So understand that when you put these into your calculator, you have to close the brackets. You have to close the parentheses there. We'll go times 10. Now, what do we get? You get the right answer. Okay, so we have one example there of how we could use the sine function to figure out what the length of one of our sides would be. So with this paper open now and a calculator ready and then in the right mode, we're going to fly through these problems. If I move too quickly, then slow the video down, pause it, but you need to make sure that you have sketched out every one of these diagrams and filled in everything that you're going to see on the board. All right, so let's start off with this one right here. We already worked that problem out, but just to make sure that you do have it on your paper, we have to label our sides first. This is our opposite. This is the hypotenuse. I know that because that's the opposite side of my angle. The correct trigonomic function that we're going to use, if we have opposite and hypotenuse, I have opposite hypotenuse, then sine theta is the one I'm going to have. So we'll have sine 28 degrees, and since I'm trying to solve for the actual opposite side, if I cover this up, that means I will have these two things being multiplied together. So I have sine 28 times 10 equals, on my calculator, we'll have sine 28, close that. Remember, I said before that if you leave that open, that's going to cause us to get some bad numbers. So we should have a component vector of 4.7. We're going to say all of these are meters, so that would be 4.7 meters really towards the south. We have letter B. Letter B, we have to label our sides. We have the x is the opposite side to the 15. The 8 is the hypotenuse. So we have to decide which of these will we use to solve our problem. All right. If we have the opposite side and the hypotenuse, that means opposite hypotenuse. I've got to use the sine function once again. We are trying to solve for the opposite side, so that means that I can rearrange this by taking sine theta times hypotenuse. So I'll have sine of 15 degrees times 8 equals. In the calculator, we'll go sine 15, close the parentheses, times 8 equals, we have 2.1. And again, we'll call all of these meters, so it'd be 2.1 is our vector component towards the east. We have part C. Part C, if we label our sides, here's my angle. That means that this is the opposite side, and this again is my hypotenuse. We look at our SOHCAHTOA to decide which we will use. I have the opposite side, I have the hypotenuse, so that tells me I'm going to have to use sine once again. All right, so all of these were the same way. We'll have our sine 40 degrees times the 40 for the hypotenuse. We'll have sine 40 degrees into the calculator. Always close that. Times 40 equals, we have 25.7, and again we'll call this meters, and that would be to the northeast in some direction. All right. Well, actually 40 degrees north of west is what it'll be. We go to E. E. We have the 35 degrees here. That means that this side is the adjacent side, this side is the hypotenuse. So, which trigonomic function has the adjacent side and the hypotenuse? It's not sine anymore. We have these two variables right there, adjacent, hypotenuse. So cosine is the thing I'm trying to find. And since I'm trying to identify what the hypotenuse is, I'm going to cover it up. And I see that I'm going to have to take the adjacent side, 30, and then divide it by the cosine of my angle, 35. Calculator, we'll type it in just as we see it. We have 30 divided by cosine 35 equals. So that hypotenuse would be 36.6 meters, and that would be at an angle of 35 degrees. That would be east of north. I'm going to start putting those variables on there, or the directions on there. It's the right way to do it. So we have the next diagram here. We start by labeling our sides. We have the 9 is the adjacent side, the x is the hypotenuse. So from our SOHCAHTOA, which one has adjacent and hypotenuse? That's this one here. So that's the one I'm going to use. I'm trying to identify the hypotenuse, so I cover it up, and it tells me that I'm going to need to divide the adjacent side, 9, by the cosine of 12 degrees. We'll have a calculator, we'll have 9 divided by cosine 12 gets you a value of 9.2, we'll call it meters, and then this is going to be 12 degrees north of west. All right, we go to letter G. Letter G, our angle is up here at the top, so that means that the x is again the adjacent side, and the 3 is, in this case, the hypotenuse. So from our list of formulas now, we need to see which one has the adjacent side and hypotenuse. That's this one. It's cosine once again. So you're trying to find the hypotenuse this time, or I'm sorry, the adjacent side this time. So I'm going to cover this up. That means we're going to have to multiply those two variables together. So I will have cosine of 45 degrees times 3 equals. All right, we'll have in the calculator cosine 45, close that, times 3 equals. This value would be 2.12, and that would be, again, meters, and our direction for this one, we would just say that this guy would be 0 degrees south, straight down. Go to H. Letter H, our angle is at the bottom here. So what we'll have is the 8 is the opposite side, the x is the hypotenuse. We need a formula to pick, so we go to my diagram here. I have hypotenuse opposite, so that means opposite hypotenuse. I'm going to be working with the sine function. I am trying to solve for the hypotenuse, so I'm going to cover it up. So that means I'll take the opposite side, 8, divided by sine 25. So I have 8 divided by sine 25 equals, and that's going to be a value of 18.9. Now with this one, since we don't know how many degrees off of true north this would be, I'm not going to put anything down in terms of cardinal directions, okay? Let's go to I. Letter I, we have our angle here. That's 24 degrees, so that means 12 is the opposite side, and the x is the adjacent side. We have to pick from our list which one has those two variables of opposite and adjacent. I see opposite, adjacent. Looks like I'm going to be working with tangent this time. So in this particular question, I need to solve for the adjacent side, so I cover it up. And I see that I'm going to take the opposite of 12 divided by the tangent of my angle, 24 degrees. In the calculator, 12 divided by tangent 24 equals, that value would be 26 point, oh boy, let's just say 27, because let's round that off. We'll say 27 meters, and this would be 24 degrees north of east. So it's 24 degrees north off of the eastern direction. So we go to J. Letter J, our angle is at the bottom. 1.5 is the opposite side. That means the x is the adjacent. On our list of formulas now, I see that I have opposite and adjacent to work with. That tells me that I have to deal with tangent. So out of that tangent, I'm trying to find the adjacent side. I'm going to scribble it out. That means I'm going to have 1.5 divided by tangent 68. We'll go 1.5 divided by tan 68 equals, and that's going to be a real small number. That's okay because that's a small side, right? 0.6 meters, and our direction for this would be 0 degrees. Oh, I almost put east. Ooh, that would have been bad. West, like that. All right, we go to letter K. Letter K, our angle is at the top up here. That means the x is the opposite side, the 15 is the adjacent side. Putting in our values now. I know that we have adjacent and opposite. That means I'm working with tangent. So the opposite side is what I'm trying to solve for, so I cover it up, and that means I have to multiply tangent 55 times our 15. So we'll have tan 55 times 15 equals, so our opposite side is going to be 21.4, we'll call that meters, but the degree here, since I'm not told like how many degrees off of the eastern direction it is, we're just going to leave our direction blank for that vector, okay? We go to letter L. Letter L, you have your angle down here, so that means you have the opposite side and the hypotenuse that's labeled. From our list of formulas, opposite hypotenuse, that tells me I'm working with sine. So the hypotenuses are unknown variable. I cover it up. I have then 375 is the opposite side, divided by sine of 55 degrees. So 375 divided by sine 55 equals, this would have a value of 457.8. We'll leave it at that. All right. And again, since it's not directing us to what that would be, I guess we could have this right here. If you go with, I guess we could figure out what that angle would be, but we're not going to for right now. We don't have to do that right now. We go to letter M. Letter M, you have your angle right here. The X is the opposite side. The 0.7 is the hypotenuse. So from our list, we know opposite, hypotenuse, I'm working with sine. I'm trying to solve for the opposite side, so I'm going to have to multiply those two values together. So I'll have sine 49 times 0.7, sine 49, close that, times 0.7 equals, our value would be 0.53 for that. We'll leave the angle off since we don't have it being a true north, south, east, or west. We go to letter N. Letter N, our angle is up here. This is the opposite side. That's the adjacent side. So from my list, which one has opposite and adjacent? Opposite, adjacent, I'm working with tangent this time. Out of that particular one, I'm trying to find the adjacent side, so that means I have to take the opposite, 37, divided by the tangent of our angle, 62 degrees. So 37 divided by tan 62 equals, we have 19.7, all right? So 19.7, and that would be at a 0 degrees west, since that's along a nice straight line there, or along our axes. We have O. O, we've got our angle here, so this is our opposite side. That's the adjacent side. We put in our values, shrink it up. Adjacent and opposite, that means I'm again working with tangent. I'm trying to solve for the adjacent side, so I'm going to have to divide the opposite of 115 by the tangent of 70. We go 115 divided by tan 70 equals, our value here is going to be 41.9. We'll just round it off at that. And again, since we don't have the other information, we will not worry about that for this time. We got a couple more. We have letter P. You have your angle here. So that means that this is our hypotenuse, and then this is the adjacent side. From our list, we've got, we'll put it down here. We have hypotenuse and adjacent. Hypotenuse, adjacent, I'm working with cosine. I am trying to find the adjacent side, so I scribble it out. That means I'm going to have to multiply the cosine of 21 degrees times the hypotenuse of 1.5. cosine 21, close it, times 1.5 equals, that would have a value of 1.4 meters, and we would say that that would be at a 0 degrees due west. Last one here. We have our angle, we have the hypotenuse here, and then we have the adjacent side over here. From my list, which one has the hypotenuse and adjacent? Adjacent hypotenuse, I'm working with cosine. I'm trying to find the hypotenuse, so I'm going to scribble it out. That means I have to take the adjacent side of 352 and divide it by the cosine of my angle 43. We have 352 divided by cosine 53 equals, you have a value of 584.9 meters, and that would be this would be 53 degrees south of west. Now, we just went through and answered all of our problems. What you have to do now is take a snapshot and submit those pictures to Schoology in order to get credit. All right? If you had any problems, make sure that you ask and I'll work you through them. All right? Take care.